Write 3x to the fifth plus 12x to the fourth minus 36x cubed in factored form. How do I write something in factored form? My teaching assistant Chloe is here with her latest cheat sheet notes. She wants you to know that when you are factoring, ask yourself, can you pull out a greatest common factor? And then there are 4 factoring patterns that we're going to talk about: difference of squares, perfect square trinomial, difference of cubes, and the sum of cubes. And when you are raising a power to a power, you multiply the exponents together. Now that we have Chloe's cheat sheet notes, we can see that the first thing that she wants us to look at is, can you pull out a greatest common factor? I have 3, 12, and negative 36 as the numbers, and I have x to the fifth, x to the fourth, and x cubed as the variables. So when I'm looking at this, I'm going to go ahead and look at each one of the factors for 3. I know that 3 could be 1 or 3. I know the factors of 12 are 1, 2, 3, 4, 6, and 12. 1 and 12 make 12. 2 and 6 make 12. 3 and 4 make 12. And I know 36, we could do 1 and 36, 2 and 18, 3 and 12, 4 and 9, or 6 and 6. So what is the biggest number that all 3 have in common? That would be their greatest common factor, just the number part. And I can see the biggest number they all have in common is a 3. So I'm going to go ahead and pull a 3 out. But now let's go ahead and look at the variables. I have x to the fifth, x to the fourth, and x cubed. That means I have 5 x's, 4 x's, and 3 x's. What's the most I can pull out of all 3 of these? Well, they all have at least 3 x's, so I'm going to be pulling a 3 out and an x cubed. So you can see that's what I did here in my next step. I picked the 3 out because that's the number we pulled out of all 3 numbers, and then I pulled x cubed because that was the biggest variable I could pull out of all 3 terms. Now, what is remaining? Well, 3x squared times x squared would give us 3x to the fifth. Remember, when you're multiplying 2 powers together with the same base, you add their exponents. 3x squared times 4x would give me a positive 12x to the fourth. And 3x cubed times negative 12 would give me negative 36x cubed. From here, I have another polynomial. I already pulled out the greatest common factor, so we're just going to put that to the side for right now. But let's look at x squared plus 4x minus 12. When we are solving these, there is a little trick you could do, is to make a table and ask yourself, all right, my leading coefficient, which is the coefficient in front of the largest degree term, which in this case, our leading coefficient is 1, and multiply it by your constant, which is negative 12. So 1 times negative 12 is negative 12. List all the possibilities of 2 numbers that can multiply by each other to give negative 12. I could do 1 times negative 12, negative 1 times 12, 2 times negative 6, negative 2 times 6, 3 times negative 4, or negative 3 times 4. Those are all the possibilities to get negative 12. Now the next step is look at the number in the middle. So our b, this is in standard form, remember, ax squared plus bx minus c. So we have our b, which is 4. Added together, they have to equal 4. So what's 1 plus negative 12 is negative 11. Negative 1 plus 12, 11. 2 plus negative 6, negative 4. Negative 2 plus 6, 4. 3 plus negative 4, negative 1. And negative 3 plus 4 is equal to a positive 1. Now, in which case do we actually get multiplied by negative 12 and added together equaling 4? And that is right here. So our 2 numbers are negative 2 and positive 6. So because our leading coefficient, the a position, was a 1, we can go ahead and break this down to x minus 2 and x plus 6. So when I come back up here, I still have that 3x cubed out in front, but I'm going to have x minus 2 and then the quantity x plus 6. This is my final answer right here in factored form, and it's completely factored.